Hello, and welcome to this Gagemaker webinar. My name is Katie, and I will be your IEEE Global Spec moderator, and I would like to review a few items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the Speaker Bio window with background information on today's presenter. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce today's presenter, Eric Otten. Eric is the Vice President of Sales and Marketing at Gagemaker. Eric, welcome to today's event, and with that, I'm going to pass things along to you to get us started. Eric, go right ahead.
Hello everyone, my name's Eric Otten with Gagemaker in Houston, Texas, and welcome to our webinar. This webinar is about the benefits of implementing a precision horizontal measurement device in your facility, which we're going to call a PHMD from here on out. And I'm really excited to hear from you at the end of our session. We'll be fielding some questions during an active Q&A segment. The webinar will be available online for subsequent viewing. Let me tell you a little bit about myself and my background and experience. So for the past 2 decades, my experience involves operations, manufacturing tubular products for oil and gas, precision measurement, and then thread inspection, and then also some experience with calibration equipment. So purchasing precision measuring equipment can seem very daunting given the initial upfront expense, but when you appropriately deploy it and utilize this equipment to its capability, that initial return on investment occurs very fast. So the name of the game is versatility, accuracy, and flexibility, and this webinar is going to explore the pros and cons of choosing a PHMD over other common traditional devices. And we're going to demonstrate the 4 ways to accelerate your return on investment and provide you insight on why your facility may be missing out by not owning and operating. So now let's give some detail on what a precision horizontal measuring device, or as I said earlier, a PHMD is. So it's a highly accurate benchtop piece of equipment. It's typically made up of a combination of a single axis, very precise linear bearing, and also an ultra-high accuracy scale. And those 2 things are used in conjunction in a shop or laboratory for part measurement, gauge setting, and then for calibration. Some of the names used to describe a PHMD are a linear measurement device, a measuring master, sometimes they're called presetting or calibration benches, an industrial length master, or a universal type measuring machine, and then the one we offer is a mic track. So now that we know what a PHMD or a mic track is, let's talk about who needs one. In our opinion, everyone does. Basically, any facility that's performing receiving inspection, facilities that perform threading operations, especially in oil and gas sector, companies that have a dedicated calibration lab or a gauge lab. There is a definite need across all these major manufacturing industries, aerospace, automotive, energy industry. Basically, if you don't have one, you're missing out on these benefits. Everyone should have a PHMD. Let's start by increasing sales. Owning a PHMD expands your capability and essentially grows your shop floor capacity. How? The versatility involved with these types of machines allows your facility to immediately measure parts or set gauges with extremely high accuracies on a greater variety of applications. That speaks to brand recognition. The high accuracy measurements that follow by deploying a PHMD elevates your level of quality, which is in turn going to improve the product you produce, and your industry credibility follows suit. That means less time wasted waiting on outside suppliers. It's putting the control back in your hands, saving you time and money. All of that lends itself to your return on investment. Let's look explicitly how. As we said earlier, the purpose of this webinar is to highlight the 4 ways you can increase your ROI with a PHMD. Let's explore those 4 ways. Number 1, gauge setting. No more need for gauge blocks or expensive dedicated masters. Use the PHMD's versatility to set gauges with very minimal training. Number 2, part measurement. Part measurement can be one of the most difficult applications in any manufacturing or receiving inspection application. But part measurement with a PHMD is easy. Again, utilize the right fixture and measure away. Number 3, shop versatility. So realize the immediate benefit on the actual shop floor by being able to do things you couldn't do before. Essentially, you're diversifying your business prospects by being able to do a greater range of applications or take on jobs in industries that maybe you couldn't bid on before. Number 4, calibration. No other benefit is as invaluable as this one. Every instrument calibrated in-house saves time and money, and all that goes straight to the bottom line. So common industry-wide practices for presetting, setting, or standardizing hand gauges is to utilize tools that are typically available in the shop. So these may include OD and ID mics or micrometer style gauges. Gauge block stack-ups are very popular, or Joe blocks, calipers, and then of course dedicated setting masters or fixed limit gauges. So in contrast with the typical methods I just named, we're also going to look at the benefits of setting gauges with a PHMD, like a mic track. While there are pros and cons associated with each method, let's investigate further. First, let's examine using a dedicated setting master. So the pros are immediately obvious. They're accurate. It takes minimal training because they're robust, pretty much dummy-proof design, and it's a simple concept. However, the cons easily outweigh these benefits. So what are the cons? Well, first, setting masters, depending on how often they're used, tend to wear out over time. They're non-adjustable, so that means you require multiple sizes and types, and you may end up needing a lot of them. Storing a host of setting masters takes up space in your lab or shop and gets expensive very quickly. Ordering non-adjustable setting masters comes with other headaches like long lead times. They're often made to order, so they're not easily replaced if damaged or lost. In addition to dedicated setting masters, gauge blocks or Joe blocks present an equally popular method for gauge setting. Compared to setting masters, gauge blocks present a much wider range of versatility. There's no real loss of accuracy, and most shops have some on hand, and if they don't, gauge blocks are easy to get. Now, the cons are also apparent. So operators are prone to making mathematical errors during the stack-up process. Gauge blocks are small, so they tend to get dropped or damaged, sometimes even lost. They require expensive calibration, and users often need training in order to achieve the right gauge block stack-up for the setting value. Now let's take it a step further and compare to micrometer style gauges. So every machine shop has a set of OD and ID mics. This is a very common practice to measure product with them and set gauges with micrometer style instruments. However, doing so can be very cumbersome. It's time consuming. And now this is where you really start to see a loss in accuracy as opposed to a dedicated setting master or the accuracy you achieve with gauge blocks. In addition, while they're adjustable, that range of adjustability is limited. It's based on the range of the instrument, so you still may need multiple OD and ID mics to achieve the same task that you could with one robust PHMD and some fixtures. So summarizing the pros, you have that limited adjustability. You still have some accuracy and they're readily available, but the cons are they're fragile instruments that have to be individually calibrated. They add to your operation cost. And then there's that loss of real accuracy compared to the other setting masters we just discussed. So let's highlight the example of a MRP gauge that's used for oil and gas pipe threads. That style of gauge involves an indicator and contact shoes. And here, if you look at the exploded view, you can see the anvils are going over the shoes, and these are the anvils of the OD micrometer. So in order to set the MRP with an OD mic, you have to adjust the OD mic using the thimble, lock it into place, sweep over the shoes up and down, back and forth, very cumbersome, and then zero the dial. So it's much more cumbersome, less accurate, and time-consuming. than compared to a PHMD. Now let's present the value proposition of setting that same MRP style gauge, but on a PHMD mic track. So I've installed proper fixtures for the application. I've dialed in a setting value, locked it in, so it's now mimicking the robustness and the accuracy of a dedicated setting master. But if I want to change the setting value, all I do is dial it in and lock it down again. I don't have to go out and purchase another setting master. Because of the geometry of the fixture, I put the MRP gauge on, I date them off the face, I zero the dial. Don't really have to do any gross sweeping like I would with a micrometer or a set of gauge blocks. Very robust, very simple, too easy. While clearly the best option, there can be some negatives. And typically the first thing that comes to mind is there's a high initial upfront cost when procuring a PHMD. There's some limited portability. You have to have somewhere stable to place it. And if it's damaged, this is a substantial piece of capital equipment, so it could be expensive to repair or calibrate. However, this doesn't even come close to approaching the value proposition that a PHMD like a mic track offers. Now let's explore the benefits. Number one, the ease of use. There's nothing else like it. Dial in on a digital readout or an attached PC on a PHMD. The setting value with almost infinitesimal adjustment, too easy. The fixtures, I can't stress enough, using the fixtures to leverage the unit to its fullest capability. Just allows for such a variety of measurements and setting gauges, and later you'll see calibration. And you get to achieve all this without any loss in accuracy or repeatability. That's the key. It's fast and reliable, easy to use. So the second way to achieve a quicker ROI with a PHMD is to utilize the unit for part measurement. So traditional part measurement typically involves OD, ID mics, micrometer style instruments, hand gauges, calipers, and even go, no go gauges. And then you can go as far as something very accurate like a CMM. So there are advantages to using the hand gauges because they're already available, and that's the most traditional way to measure a part. And there is some versatility there. And then for a CMM, the biggest pro is they're extremely versatile for difficult geometries, and they're very, very accurate. However, when you're comparing to a PHMD, the hand tools have limited accuracy and they're not dimensionally stable. So there's repeatability and reproducibility issues from one operator to another. And you really need a huge assortment of gauges to achieve a practical range of measurement. So on the CMM side, while these units are extremely versatile and have very high level of accuracies, the buildings and facilities required to house a unit like that, they're big. It takes up a large footprint. There are environmental conditions that have to be maintained. And then a person can't just sit down and start using one of these types of devices. You have to get training and they also don't have the
Okay, great. Eric, thank you so much for that great presentation. We are going to move into some questions that have come in from our attendees. If we don't get to your question, everyone, don't worry. We will have an answer for you following the webinar. The complete Q&A transcript, including answers we did not have time for, will be sent to all of our registered attendees, and they will be posted in the webinar when it goes into the on-demand mode. Now, for anyone who would like to ask a question, just go ahead and enter it in your Q&A window there and click submit, and we will get those questions answered. So let's start off with the first question here. Can this device calibrate adjustable ring gauges?
So the answer to that is with the appropriate fixture, you certainly can. But there's different rules on whether or not that is a valid calibration, depending on what specification you're holding to. So what's typical An adjustable ring is usually calibrated with something called a set plug. So oftentimes people will take the set plug, calibrate that on the PHMD or the mic track, and then take the set plug and calibrate the adjustable ring gauge. But it can physically do it. It's accurate enough, and at some point the ANSI specs may allow that. Right now they want you to use a set plug.
All right, great. Eric, thanks for that answer. We're going to move on to the next question that we have in here. How many instruments make sense to buy a mic track?
Okay, so that question is really, you have to look at two different avenues. One, if you're talking about part measurement, then you have to compare it to what is the comparable method. So if you were buying dedicated setting masters, let's say those cost on average $500 each. Well, the setup that we're showing in the video of a mic track and the appropriate fixtures to set gauges, that's typically around in the neighborhood of $15,000. So if you had the choice of either purchasing 30 $500 dedicated setting masters, then you may as well go ahead and buy a mic track because you're already at a break-even point. Everything else from there is great. Gravy. If you're looking at calibration, typical calibration costs, like we said in the webinar, are anywhere between $50 and $100. So back of the envelope math, if we were choosing $60 to answer your question, how soon do you want to break even on that investment? If you want to do it in 1 year, if you have 250 instruments times $60, that's $15,000. The instrument has already paid for itself.
All right, great. Thank you for that answer. Just remember, everybody, if you want to ask a question question, go ahead and enter it in that box and click submit. The next one we have here, Eric, is what is the typical break-even time after implementing in-house calibration?
So I think I've kind of answered that one in the previous question. So if you're doing somewhere between 200 and 300 calibrations a year, based on that cost, you're looking at 1 year or less on your return on investment. If it's part measurement, you need even, not part measurement, I'm sorry, gauge setting, you need even less instruments because those setting masters are typically in the hundreds of dollars, so it could be just 30 or 50 instruments to break even after a year. 1 year is very reasonable.
Okay, great. Thank you. We do have another question that popped in here. What is the standard accuracy needed to calibrate hand gauges?
So a good rule of thumb is whatever the hand gauge is, whatever its accuracy and resolution, let's, for example, use a dial indicator that has 1/1000th graduation in accuracy. So a typical rule of thumb is you'd like to be 5 to 10 times more accurate with your traceable setting calibration device than the instrument you're trying to calibrate. So if I was trying to calibrate a dial